Good day, this is Ian Aragoza, and this is my thesis entitled Modeling Poverty in the Philippines Using Public Geospatial Datasets. Poverty is one of the biggest problems we face today. It's defined as living with just under $2 a day to meet your needs. 17% of people in underdeveloped nations live in extreme poverty, and many more are at risk of joining them. In order to tackle poverty, we first have to know where poverty is most present. Poverty mapping is an important tool in identifying the most poverty stricken communities so that institutions can allocate resources towards solving poverty in the poorest areas. But many underdeveloped countries, the most affected by poverty, have stunted infrastructures to gather data for poverty mapping. In the Philippines, they measure socioeconomic indicators through a survey that needs millions of pesos, months of work, and massive amounts of manpower. This leads to data that is both expensive and late. What solution has research come up with? Well, studies have started popping up in the age of big data that use open datasets to train machine learning models that can predict socioeconomic indicators. So, in a poverty stricken country that lacks data infrastructure like the Philippines, what datasets exist to be an alternative for poverty mapping? We have the NDHS that measures the socioeconomic status of the country and measures poverty through a score called the Wealth Index. We have an internet performance dataset containing information on download speeds, upload speeds, and latencies from users. We have a night lights intensity dataset that shows how bright regions of the world are at night, and we have the OSM dataset that shows the geometries of buildings, roads, and different points of interest. We clean up and process all these datasets, then we see how well we can predict the target wealth index using a machine learning model trained on the rest of the data. In the study, we consider linear regression models and a random forest regressor. We evaluate the final model with the R-squared value to show how much of the variation of the target is explained. The best performing model can explain up to 63.3% of the variation of the wealth index. In conclusion, we clean public datasets and use them to train a machine learning model that explains 63.3% of the variance in wealth index. Running the model takes hours, needs no budget, and can give predictions quarterly. This gives us direction in using open data and machine learning as an alternative to traditional methods of poverty mapping, upon which future studies can improve further on. Thank you for listening to my thesis.